Hello there, it's Julius from Aalto University presenting our recent endeavor in vision language pre-training problem. So this work is about how do we pre-train a vision language model that's relying on paired information as supervision. So over the past few years, we have seen some trends in vision language pre-training research. So it's either on the scalability perspective, whether a model can be gracefully scaled up with more data, or whether a model can be versatile enough to be well transferred to as many downstream tasks as possible. And in this work, we are very much focused on the data efficiency parts, where in the traditional setting, we have to give the model a pair of images and text. And in this work, we only fit in the model with a bunch of random images and a random text. When we ask, can we still learn the visual language alignments from the unpaired image text data only? This is the proposed method in action. We propose a visual vocabulary-based feature hallucinator, or WFH, to generate correspondences from texts across domain. So given an image, we detect the region of interest. And for each region of interest, we detect the object and the attributes associated with the region. And WFH is trained to translate the embeddings of those objects and attributes into the correspondences in visual domain. And why is that useful? Because then WFH is able to generate cross-domain correspondences for a random sentence. So given a sentence like dog is barking, WFH is there to firstly contextualize the input tokens and then translate each input token into the correspondence. And those correspondences or hallucinations are then paired up with the input sentence, and then they are all together fed into the transformer encoders and acts to predict the mask tokens as in max language modeling objective. So for full details of the models in a working of WFH, please refer to our paper. We conducted our experiments on 4 different downstream tasks over different data sets. And our quantitative results show that, for instance, on cross-modal retrieval, we outperformed the previous state-of-the-arts U-VLP or UVB shown here under the similar weakly supervised setting. Also, our proposed model outperforms UVB consistently on other downstream tasks. Now, we compare the level of cross-modal fusion with attention probabilities to analyze different behaviors of U-VLP and the proposed model. Over each plot here, the x-axis shows the index of the transformer layer, and the y-axis shows the attention probability values. And each curve here shows how the attention probabilities evolve over layers for each attention head. The main message here is that if we look at text-to-image cross-attention probability values, our model basically accepts a higher level cross-modal fusion already in the earlier transformer layers. So to summarize, we propose WFH to address the lack of pair information under weakly supervised pre-training setting. And the proposed WFH basically generates some meaningful hallucinations that could breach vision and language domains. And our results shows that the proposed models basically outperforms U-VLP, which is the previous state-of-the-art, on various downstream tasks. For full details of the paper, please talk to me at the conference or simply check out the paper. Thank you.